So now in this video, we will solve the 16, 17 and 18 question of part C. So the 16th question says using age and productivity data, normalize both attributes using Z-score normalization, and the B part is compute Pearson's correlation coefficient and covariance. Also comment on whether the relationship is positive or negative. So in this n is equals to 18 pairs. So we need to normalize both attributes using z-square normalization. So the normalized z-square for any value v is z is equals to v minus v bar by sigma. So in this way we will we will normalize both the attributes using z-square normalization. Then the B part is compute Pearson's correlation coefficient and covariance. So the covariance is measures the linear relationship magnitude, that is unscaled. So this is the formula of covariance. So in this way, when we will put all the values in this formula, we will get the covariance formula as 19.34. Then Pearson's correlation coefficient. So it measures the linear relationship strength and direction, that is scale. So when we will put when we put the values in this formula, we will get the Pearson's correlation coefficient as 0.081. Then we need to comment on relationship, that is the correlation coefficient. So it is it is greater than 0, that is 0.081. So it is positive, and this indicates a very weak positive linear relationship between age and productivity. As a student's age increases, their productivity score tends to slightly increase, but the relationship is not strong enough to be highly predictive. Now moving on to the 17th question. So the 17th question says, suppose student project evaluation scores are from 5 to 215. Then partition into bins using equal frequency partitioning and equal width partitioning. Then the C is clustering. Hmm. So in this, the data is given. Now the A is equal frequency partitioning, and the depth is given 4. So we will create the 4 bins and put the values, three values in each part. Then its characteristics include the bin have an equal number of records but highly unequal widths. This is useful for dealing with skewed data where you want uniform sampling across the distribution. Then B is equal width partitioning, that is 4 bins. So range goes as max minus min, that is 215 minus 5, that is 210, and the width as 52.5. So we use a bin width of 53, bin boundaries as 5 to 58, then 58 to 111, then 111 to 164, then 164 to 217. So in this way, when we will calculate the bin values, so bin 1 has count 8, that means 8 values. Bin 2 has count 2, bin 3 has 0, and bin 4 has 2. So the bin have equal weights but highly unequal counts. This is simpler but can result in empty bins and poor data distribution across bins. Now the C is clustering. So in this we use a clustering algorithm, that is k-means with k is equals to 4, to automatically determine the bin boundaries such that data points within the bin are highly similar and bins are highly dissimilar. Characteristics क्या है? So this is the most data driven method. It creates bin that represent natural grouping or peaks in the data distribution, which is superior for complex or multimodal data. The resulting bins would likely separate the initial low scores from the high outliers. Example, one bin for less than 20 and one for 30 to 70 and one for 1 or 2 for the scores greater than 90. Now moving on to the last question of part C, that is 18th question. So the 18th question is use a flowchart to summarize attribute selection techniques for feedback analysis. So A is forward selection, B is backward elimination, C is hybrid method. So in this forward selection, so start with an empty set of attributes. Add the attribute that provides the best performance gain when combined with the current selected set. Then repeat until a stop criterion is met. Example, maximum number of attributes reached or performance stops improving. Then the B is backward elimination. So in this, start with the full set of attributes. First, remove the attribute that results in the smallest performance loss when eliminated. The second is repeat until a stop criterion is met. Example, minimum number of attributes reached or performance drop below an acceptable threshold. Then the C is hybrid method. This attempts to combine the speed of forward selection with the robustness of backward elimination. The search starts in the forward direction, adding attributes, and the second is it periodically performs a backward step, that is eliminating the weakest attribute to remove any variable that may have become redundant after new variables were added. So it was all about part C. We'll solve the D part in the next